First QA Hub. Hello everyone. We are starting our first Digital QA Hub conference. It's our first such conference, and we will have a topic about mock server, about ML products, and about relationship between QA and developer team. And our first tech talk will be about mock server from our speaker Zhanna Kurafeeva, senior software testing engineer. Jana now will start her tech talk, and before her tech talk, we will send you feedback form now in the chat about our QAHub conference. Your feedback, your opinion is very important for us, and after conference, after tech talks, you can vote and write your feedback. And now, word to you, Jana.
Thank you, Irina. Sorry, problem with my earbud. So welcome to our conference and to the first tech talk where I will talk about mock server and how do we as testers use it to emulate errors during integration testing. So I would like to start with a little bit information about me. My name is, as Irina already have told you, is Zhanna Kurafeeva, and I joined EPAM in 2019. And actually, the project that I'm working at the moment, this is my first project in EPAM, and I joined this project as a junior tester. Now I am a senior software testing engineer, and for the past 8 months, I have been a team lead on my stream. And I also have broad experience with UI and API testing. And for a year and a half, I worked in a stream where we had purely backend testing. There was no UI. So that was challenging and interesting at the same time. And to give you the idea of what we are going to talk about on the next slide, I will give you this information. We will talk about what is the mock server, why do we use it, how do we use it as testers, and I will give you a short demonstration in screenshots. Why in screenshots? Because due to confidentiality reason, I won't be able to show you any of the real data, so it will be done in the screenshots. And yeah, this is what we're going to talk about today. So the mock server, what is it? This is actually an application that can be used for different purposes, and all the documentation can be found on the website, which is www.mockserver.com, where you can find the detailed and thorough information about how to set it up, how to use it, how it works, for what purposes it can be used, and so on. And all the information is there. And basically, the mock server can be used for any system, I believe, that is integrating using either HTTP or HTTPS protocols, and it can be used as a mock, as a proxy, and both depending on your needs, depending on what you want to do, as a proxy and a mock. And let's talk about that a little bit more. A mock can be used actually in different cases. It can be used when you don't have any integration yet, but you want to like to test this integration with the other systems. So you can set your mock to respond with specific responses, and you can test how your system behaves with this mocked integration. Then we have a proxy. This is the instrument that we can use when we need to either modify our requests and then forward them to the third-party system. And we can also, this can be used when we need to send specific requests and we want to somehow modify them. And in the example that I'm going to show to you today, we actually use the mock server both a little bit, both as a mock and a little bit as a proxy in the simplest way, but still I will also show you an example of how it can be used as a proxy. So let's talk about mock a little bit more. So in this diagram, you can see the simple explanation of how it works, especially if you're new to testing. This can be interesting to you. So you have your system under test that you want to test, and you want to receive, let's say, specific responses from the third-party system, or you don't have integration yet, so you can send your request to the mock server. Mock server sends you the responses that you want, and you can verify, you can test how your system handles this, how your application handles these responses from the mock server. And what is a proxy? So again, our system under test sends specific requests to the mock server. Mock server, depending on the need, it can forward it to the third-party system, or can modify, or maybe record your request so you can look at them later and test. And it can, I believe, we don't actually use it in this way, but I believe it can work with the different third-party systems at the same time. So why do we use this application, the mock server? And there are actually many other alternatives that have similar functionality. And if you Google it, there is a quite long list of the applications that can be used in this way, like wire mocks or pressed mock and many, many others. But for us, mock server works perfectly. It is adjustable. We can adjust it for different services. It matches all of our needs, quite easy to use for the testers. And it also, the most importantly, it has a dashboard that gives us the view of everything that is happening in the mock server. Another reason, so as I already told you, so how do we use mock server? Our application is integrated with many other systems, as many other applications. But what is the most common issue when we are integrated with the other system? One of the systems that we're integrated with can go down. There can be like a failure in the system, and the system starts responding. The communication between our system and the third-party system can be broken, and we start receiving errors from the system. And then an error can be displayed to our user. This is what we don't want. Our user can get confused. He doesn't know what to do next. And for these purposes, on my project, we have implemented this functionality that is called design for failure. This is the design that is showed to the user whenever an error comes for the third-party system. So we covered, I think, almost all of the services that can respond with an error, and we have this specific design that is shown to a user, and the user is not that confused. He knows what will happen next, what will happen with his process, and as a result, we don't lose the user. He reassured that, let's say, everything will be okay with this design for failure. But what is the problem with the design for failure? Testing errors, like errors, happen when we don't want them. So, but for design for failure, to test these errors that come from other systems, this is quite unstable. We cannot, thankfully, guarantee that the third-party system will respond with an error. This is where our mock server comes to help, and we can use it to emulate errors. So we specifically use it for emulating errors that come from the other system, and it enables us as testers to be able to test the design for failure at any time. So on the next slide, we will start with the demonstration. I will go through the usage of the mock server step by step, how when we need something from the design for failure to be tested, I will show you what we do. So the first step, what we want to do, we want to change the configurations of our system under test, and we want to change. We want our system to start looking not at the actual URL, but actually at the mock server URL. And in order to do that, you can see that I'm using a kubectl command. So in order to use it, you need it to be pre-installed on your machine. Testers usually have it. So here I want to access the config map of the pod of the system. And when I send this command, a txt file is opened where I will, let's say we have this integration URL, and remember that all of the data is fake here due to confidentiality reasons. I cannot show you the real data. So let's say we're integrated with Google, and I want to change the actual URL with the mock server URL. So when I do this, I save the changes, and for the changes to be applied in the system, in the pod, I need to delete the pod. When I send this command, delete pod, the pod will then restart, and all the changes will be applied in this restarted pod. And because the mock server URL, it's not like exposed, it's not open, we want to forward the port of the mock server to my local machine so I can access the mock server through Postman. So the next thing I want to do is send this command here to forward the port to my local machine, and now I can access the dashboard of the mock server, and you can see how it looks. We have different sections here. We have section log messages. This is where we have all the information about what is happening in the mock server. Then we have section active expectations. This section shows us all the expectations that are set in the mock server at the moment. In the received requests section, we see all the requests that were received by the mock server. And here, of course, you can see a request that was proxied, that was forwarded to the third-party system. So you can see that I have quite a lot here. I just accessed the dashboard, but I already have something here. We don't want this. We don't want any of this to, like, let's say somebody else did this. We don't know what is it for. It can interfere with our testing. And what we want to do, we want to clear everything up. We want to reset the dashboard to the empty state. And to do that, we will send a put method request with empty body to the mock server reset. So you can see that I receive 200 status here. And if we look at the dashboard, you can see that it's cleared. We don't have any active expectations, like everything is clear here, apart from the log messages section. Here we have one message that tells us that mock server has been cleared and there are no active expectations at the moment. Here it is. Next thing, this is actually a proxy expectation. I will send the first expectation for my testing to the mock server. Again, a put method. This is the endpoint. This is how it looks like, mock server expectation. This is the request that we are sending to the mock server. And you can see that I want to set the expectation so the mock server is redirected to our actual third-party system. And the priority of this is -1. So it says that it means to us that whenever we have an expectation with higher priority in the mock server will match to that expectation. And when we don't have any other expectations, this will be our next expectation in the list. And if we look at the response, you can see the ID here that we received from the mock server. Let's have a look at it. It starts with 4C4 and ends with F8A. And you can see that time to live, it is set to unlimited period of time. The flag is true here. And it means so that when we don't have any other expectations set in the mock server all the time redirects us to the google.com, to the actual URL. In the next request, I want to send, let's look at the log messages here. You can see that we have one expectation that appeared here. It's the same ID that we received in the response, 4C4 F8A. And we also see a new message in the log messages that tells us that the first expectation was actually created, and it has the same ID here. Next one, this is the moment that was all the hassle for. We will set our error expectation. This is the same endpoints, the same method, but slightly different request. Here you can see that we are also sending time to live, and we setting the error for 120 seconds. And for this amount of time, we want to receive status code 500 from the mock server. And in the response, we again receive an ID for our expectation, and it actually is set for the period of time of 2 minutes. And if we look at the logs here, you can see that we have a second expectation that appeared here. This is our error expectation. And also we can see here in the log messages that a message about this. In the next slide, this is the moment where we actually want to test how mock server works. Because I cannot show you the real application or send any of the real requests, to show you how it works, I will send a request to mock server, just like simple get request to the mock server, and we get a 500 error. This is what we want. This is just to give you the idea of how it works. And if we look at the logs here, you can see that first thing what we did, we created our error expectation, and then mock server received the request. And this request matched this expectation here. And because it matched the expectation, we received the response with 500 status code from the mock server. So yeah, and on the next slide, I will go through the process again, just to give you everything like in a nutshell, and to go through the process again. So the first thing that is happening, we set up the default redirect to our actual service that we are integrated with. Next thing what we do, we set up an error expectation for 120 seconds for 2 minutes. Then mock server receives several requests, and all of the requests receive 500 error, because this is what we set in our expectation. Then after 2 minutes, you can see that the error expectation was removed from the mock server. We have a message about that. And our next request that mock server received was forwarded to our actual URL. In the received request, we can see all the requests that were received by the mock server. We can see our forwarded request. And here in the active expectation, you can see that we have only one expectation. This is the default redirect expectation, because the error expectation, as I previously told you, was removed after 2 minutes, and that's why it's not displayed in the active expectation section. So in a nutshell, this is basically how mock server works, the use case, how we use it on our project. And to sum everything up, after you finish your testing, the next thing that you want to do, you want to return the configurations in the bot to the actual values. How we do it? We can do it in the same way. We can access the config map of the bot and change the configurations manually, or we can just redeploy the service and all the default values will be reapplied to the in the service. You also need to keep in mind that this kind of testing blocks other teams and other testers, so it should be planned in advance, and you want to let other testers know that you're going to work with the mock server. Another thing that helps a lot, helps a great deal if you have a detailed instruction on a project, either for the newcomers or even for yourself, because on my project, we don't test this design for failure quite often. So it can happen from time to time. So you just want to refresh your knowledge, and instruction helps a lot. You can forget something, it's okay. And you also may need some help for the initial setup of the mock server on your project, or you can just have a look at all the documentation where everything is explained on the website, which is www.mockserver.com. And this is everything that I wanted to tell you about the mock server today. And do you guys have any questions? Irina, are
Yes,
there any questions? Mm-hmm.
yes, thank you very much for your tech talk. Now we're starting our Q&A session. You can write your comments in our chat. And for now, we have some questions that was in our VR community page. And now I will start with them. What are the use cases for the mock server? First question.
Sorry, can you repeat the question?
Yeah, what are the use cases for the mock server?
Yeah, so first, when you have a new application and you don't have any integration yet with the other services, this is where you can use the mock server. And like from my experience, and also this case here, when you want to test the behavior of your application, how it responds to different errors from the other systems. So I think maybe there are some other use cases. You can have a look at the documentation and just to get the idea how it can be used.
Okay, thank you. We have another question in our chat. Have you considered
Mhm.
wire mock? Sorry if I'm right.
Yeah, I can see it. No, actually, this we just happened to start using mock server, and as I told, it at the moment it actually matches all of our needs. So, but maybe we should have a look at the wire mock. But there was no need actually, because mock server does everything we want at the moment, but maybe in the future. But thank you for the recommendation, though.
Okay, thank you. And we are waiting for your questions. Another question from our portal about automation of mock server. Did you have experience? Is it automated or no?
Great question, Arina. Thank you. No, it's not automated due to several reasons. First is because it requires the change of the configurations, and for the integration for the integration um, with the mock server, and because of the complexity and because of irregular use of this kind of testing, we don't have it automated, and uh, we usually check it manually.
Okay, thank you. I have questions in our chat. We
Mhm.
can do it from Postman as well, right? Why we need to do it from mock server especially?
Um, Here, I think the reason why we do this is that part of our design for failure, it's not only receiving errors from the mock server, but we also want to test our in our system under test the retry mechanism. I haven't talked about this, but we have a retry mechanism. So after, like for example, we set like 1 minute retry, and every minute our reserve service sends the requests to check the state of the third party system. And then after some time, we want for the process to be restored. This is the part of the design for failure. So we also want to test what is happening after the third party system starts responding with the let's say 200 statuses.
Okay, thank you. We have another question. Do you think mock servers is more time saving rather than Charles or Fiddler, for example, for mocking errors?
I don't think I will be able to answer the question because I am not familiar with with these tools. Uh, this will require further uh, studying of all the three instruments and just to compare them and come with the conclusion what is better to use.
Okay, and another question. Can it mock graph HKL calls?
I
Graph
think
QL, yeah, QL calls.
yeah. I need to also to maybe read a little bit more, and maybe I can come to you with an answer a little bit later today, just to see if we can use it for that purpose.
Okay, another question. Is it mock server online service or it needs to deploy on local machine and start as own server?
Hello, Yerjan. That's a familiar face here. Yeah, it requires a deploy on local machine.
Okay, thank you. If you have another questions, Jana will be able to answer you in our chat. And thank you, Jana, again for your tech talk. It was very perfect tech talk. And you can leave your comments, your thank you words in chat and send badges to Jana. Thank you,
Yeah,
Jana, again.
thank you guys, and have a good day. And thank you for all the questions. And good luck to everyone. Goodbye.
Thank you. And we are continue our conference. Our next tech talk about ML products. Uh, and our speaker is Vladimir Sashin. Yeah, Vladimir is with
Hi
us.
everyone.
Yeah, and I remind you about our format feedback form. You can leave your feedback about our conference in this form. And let's continue our conference. Vladimir, what to you?
Yep, thank you, Irina. Well, hi everyone. My name is Vladimir Sashin, and today I would like to talk about testing machine learning based products. As an ML engineer, data scientist with a bit of software testing background, I'll tell you about machine learning, its popular tasks, and common workflow. Also, I'll show you a sample architecture and we'll talk about ML product testing aspects, common bugs, and touch ML accuracy validation. And to avoid confusion, I want to point out that we won't talk about big data. Well, machine learning is an extremely popular field used in a wide variety of applications. ML is essential for solving a lot of critical and complex business problems, from self-driving cars and chatbots to customer reviews analysis. But what is ML? Let's stick to the simple example of customer review sentiment classification, which is a very popular task. Imagine we have an online store where users can leave their feedbacks on products, and we want to understand if the feedback is positive or negative. In other words, to predict the class of the text. And there are two ways of solving this problem, ML and non-ML. Let's take a look at a quite formal definition of ML. Machine learning is a type of artificial intelligence that involves the development of computer systems that can learn to make predictions based on data without the need to follow explicit human instructions. So, non-ML way would be to develop a program that will simply find words like good, bad, love, and so on that could represent the sentiment of the text. And this is exactly coding explicit human instructions. Meanwhile, ML way is to prepare a bunch of texts with known sentiment classes and train a model on this text. So the model will learn on them to make predictions for new unseen text. So it will be able to predict the sentiment class for the new input text. And moreover, this model will consider the context of this text. It won't just simply match words from the list. And as an illustration, here's an example of two customer reviews in the upper left corner. First one is, I bought this device a week ago and I loved it. And the second one, I love the original game, but this remake is a disaster. In both cases, there are words love, but the sentiment is different and properly trained ML model will work here. But straightforward word matching, probably no. But enough about sentiment classification. I hope you got the idea of ML in general. And obviously, it can be applied not only to text. Here, the most popular data types used in ML. We already covered text, but just a small note here that it can be not only whole text, but separate words, sentences, and paragraphs as well. Another one is tabular data, when the object is represented by a row in table where columns are its features. For example, we can try to predict apartment price by its area, district, number of rooms, floor, and other features. Image data type includes any kinds of images, 3D MRI scans, and even videos. The last type is audio data, computer representation of any soundtrack. For example, a voice command to your virtual assistant or just a song. Well, we know which data we can feed into ML model. Now let's briefly talk about tasks model can handle, but only the most popular because there are dozens of them. Let's start with classification. It can be applied to any type of data. In classification, we have an item and we want to predict a class or label for this item. In our example, we have an input image, and we would expect that our model will return a class cat for this image. Other very popular task on image data is object detection. In this case, model not just predicts the class for the whole picture, but it locates multiple objects in boundary boxes and predicts label for each of them. So it returns box coordinates and label for each object. For example, here we have two cats, a dog, and a duck, and all of them are located in these boxes. Image segmentation is similar to object detection, but in this case, we don't just draw boxes around objects. We attribute each pixel to a label. Another interesting task is OCR, which stands for Optical Character Recognition. Imagine you have a paper document and you scan it. But after you do it in your PC, you don't have the actual text that you can copy, edit, or modify. You just basically have the photo of it. To extract the text from photo, you apply OCR and it returns the real text. And of course, after that, you can use any other ML model to do anything with this text. For example, to classify the topic of this text, like sports, business, tech, or sentiment, and so on. Now, let's move on to the ML development workflow, which is quite different from usual development workflow, and when we just have backend and frontend. Here we have data scientists and ML engineers, or simply ML team, that work on ML-related stuff. Firstly, they analyze and prepare the data and iteratively conduct model training experiments on this data. They train and evaluate models iteratively until they get the best one in terms of maybe the most accurate predictions or the most fast predictions. And basically, this trained model is just a file that can't predict anything by its own. That's why we have our ML engineers that prepare the model to production. They develop the serving code so that the model can actually process requests and return predicts. They deploy the model and integrate it with backend. Meanwhile, backend and frontend devs are busy with their usual stuff. And from QA perspective, in addition to usual testing, here comes the testing of ML side. That includes testing of ML endpoint and its integration with backend. And of course, end-to-end testing that includes the whole data processing flow, backend side plus ML side. Now let's take a look at sample architecture of ML app that detects some objects on PDF documents. Let's say illustrations. So we have a scans of maybe books and in PDF format, and we want to detect illustrations on the scans of these pages of these books. It's AWS based, but we won't focus on details anyway. We'll just look at it on high level. This sample architecture is inspired by the real app I worked with. So this is an example from my own experience. Here we have our main backend on the left side and model serving code with the model itself deployed on the separate endpoint on the right side. So we have a file storage, and when a PDF document or scanned book is put in it, our backend is triggered. It processes this document and performs some pre-processing steps to prepare this data for ML model. In our case, let's simplify and say it just converts PDF documents to a bunch of images, because models don't work with PDFs, they work with images. So we convert each page to image, and then for each page, backend sends an inference request to the ML endpoint. and ML endpoint processes requests, generates predictions, notifies backend, and puts predictions to the storage. After that, backend gathers predictions, post-process them, and can do with it whatever it needs, like storing in database or sending to consumers. And before we go to the testing part, the last technical detail. There are two main service types: real-time, which is also called online or interactive, and batch processing. In the first case, predictions are generated on a single observation of data in real time upon request. It's usually used, for example, when you interact with app in real time. For example, when you use your favorite mobile translate app on your mobile device, you take a photo of text or maybe just type it, and you expect the response with translation right away. So the response time may matter. In the second case, data is stored somewhere, and we have jobs that are typically scheduled to process this data in batches. And in the first case, of course, if the response time is a requirement, it should be fixed in requirement as any other non-functional requirement. Well, I hope that now you have basic understanding of ML, what it is, and we can talk about testing aspects, what makes ML products quite special. First of all, we need to make sure that the system fulfills functional requirements and fault tolerant under the variety of data the app will deal with in prod. The thing is that various data properties may affect performance of ML side app drastically. That's why it's extremely important to prepare the data for testing. Well, we need to cover the variety of data the app will deal with in real life. So to do that, firstly, we must observe properties of prod data that may affect performance with respect to requirements and known system limitations. Then we should collect these test items with extreme or border values of these properties, or maybe some items that just have some special properties. And after that, we'll use these items for testing. But well, what are these data properties that may affect functionality and performance? Generic ones are file properties like file size, format, and extension. ML side can fail on processing large files or files with certain extensions. There can be bugs in model serving code, unknown limitations, or misconfigurations. For text data, there are characters numbered in text, presence of diacritics, and just presence of different languages in text. For image data, we have width, height, and area in pixels, and all these properties may drastically affect ML endpoint or backend also, performance, and even cause failures. With tabular data, we should care about following data types and constraints of fields. To illustrate the idea of selecting such properties in data and preparing test files, let's return to our example about object detection on PDF documents. From my own work experience with such system, the following properties really affect performance. Firstly, file size. So we included the biggest file observed in prod. For example, it's more than 800 megabytes. Also, number of pages in document. It really can affect backend in this case. So we included the document with most pages, 623 in our case. Also, as model works with images and image size really matters, we included docs that contain big pages, both in terms of size in megabytes and area in pixels after their conversion to images. And for example, we had a page with height almost like 30,000 pixels, which is huge. And of course, we need a negative test when we try to process invalid or corrupted PDF to make sure the system works as expected. In that case, for example, simply returns expected error message. Now let's move on to the performance testing, which is also extremely important if we have ML in our app. Firstly, we have to check overall system performance under the high load. We should answer the question, how much data is expected to be processed in what time? Then we should prepare data items, for example, dump data from prod or generated. But here comes the really important point that our data set for performance testing should have average properties of real data, like file size, maybe length of the text documents, area of the images or pages, and so on. So for example, if in average we have in real life PDF documents that have 10 pages, 10 medium-sized pages in it. But in our performance testing data set, we have small pages in documents and in average 2 pages. This is not a very good data set for this purpose. In addition to overall system performance testing, it's also beneficial to run performance tests on ML endpoints separately. Additionally, when response time is a requirement, we should perform multiple experiments to evaluate processing time, both using items that we discussed on previous slides that have like some extreme or border values of properties, and under the high load using the appropriate data set with some average properties. Also, when scaling is configured on an ML endpoint, we should test it. Scaling is a dynamical adjustment of number of ML compute instances depending on the amount of data. So when amount of upcoming data items is more than a certain threshold, number of instances where ML model is deployed increases. This is scale up and vice versa, scale down. In other words, the more upcoming data we have, the more instances with deployed model will appear. And when amount of upcoming data decreases, the number of instances also decreases. So when testing scaling of ML endpoint, we shouldn't forget triggering it scale up and scale down. When testing integration of ML endpoint with backend, we should keep in mind that there are multiple artifacts that actually define ML endpoint, and each of them could be the source of bugs. Also, if any of the following items changes, we should perform testing. And the contact person about any of these items is your ML engineer. Firstly, we have our inference code or serving code. This is the code that is deployed on ML endpoint. It serves the ML model, processes requests, and returns predictions generated by the model. And of course, as any code, this is the source of bugs. Then we have ML model itself. Remember, this is just a file or files that define a trained model. Inference code uses these files to generate predictions, and both components are required to predict something. So we need inference code plus trained model. That's why we have to make sure that code and model are compatible and they generate expected predictions, and simply that we deployed the expected correct versions of both these items. Also, we have serving configuration. This configuration defines some request processing parameters, such as maximum allowed size of request and response payload, or maybe maximum processing time, as well as some data properties. For example, the maximum area of images that can be processed. So misconfiguration is another source of bugs, and I personally prevented some of them related to the max area of image in pixels and the max allowed size, because this configuration just didn't correspond to the real data. These parameters were lower than expected. The last item is the configuration of the endpoint where the model is deployed. In our AWS SageMaker endpoint example, it includes hardware configuration like CPU, GPU, memory, and disk size. And we must remember that ML models depend on hardware settings. That's why we should test endpoint using some large data items that we discussed. For example, there can be insufficient memory error or prediction makes too much time because of weak CPU or GPU chosen on endpoint. In addition, endpoint configuration may include auto-scaling, which we already discussed. Now, let's summarize what we already discussed in the list of common bugs. Firstly, we may face insufficient memory error that can occur on both ML and backend side. That's why we should test the app with large data items to catch this bug. Another common bug is request timeout, which can happen when processing takes more time than expected. And we can catch this bug using large data items as well. Also, our system may fail on processing items with certain properties. They border all extreme values. For example, too many pages in PDF documents, symbols in text, presence of not supported characters in text, and so on. So remember all these various properties of data that we discussed. In addition, wrong, buggy, or incompatible versions of artifacts could be deployed on a ML endpoint, including inference code or model. And the last type of common bugs is misconfiguration, when configuration just doesn't correspond to actual data. And we should know that here we have some serving configurations and hardware configurations. And last but not the least, I'd like to mention ML accuracy metrics evaluation. This is extremely important because we need to evaluate how accurate are the predictions that we generate to make sure they are good enough. Otherwise, why do we need an application that detects cats on only 10% of all photos? This is pointless, and deploying and maintaining such app in prod is just not worth it. That's why we should evaluate the accuracy of predictions systematically using statistical approaches. And this is mostly done by ML team, but as QA engineers, you should also be aware. Also, I'd like to point out a really important thing. It's really impossible to make a model that makes absolutely no mistakes. So it's expected that sometimes model, for example, can detect some cats on photos or misclassify sentiment of the text. That's why we need to measure accuracy of predictions numerically and statistically. And here comes the metrics. Metric is a numerical measure of quality of predictions. I won't dive into details because there are much even more metrics than ML tasks. But example of the easiest metric is simply the percentage of correct predicts among all predicts. And concerning accuracy evaluation, we should keep in mind the following things. Firstly, metrics and their required values should be defined and aligned with stakeholders and fixed in requirements as any other requirement. Secondly, we should have a representative test data set that has ground truth annotations. It means that it should have machine readable or in manual case human readable annotations that, for example, image number one, if we have classification task, that image number one in our data set is dog, image number two is cat, and so on. Lastly, we should run our test data set through the system end-to-end to get predictions and calculate metrics based on predictions and ground truth annotations. This is usually done automatically or manually by data annotation or processing specialists. In conclusion, I'd like to encourage you to collect inaccurate predictions and share them with your ML team, as it can really help to recognize some common errors and patterns that model is missing and improve it. So like to add to statistical approach, the manual, the visual review of data, which is also very helpful. And that's it. I hope it was very interesting and informative for you, and I'll be glad to answer your questions.
Yes, thank you, Vladimir, for such perfect tech talk. And we're continuing our Q&A session. And we have our first question in the chat. How do you test if model has learned right?
Well, so this is basically what I tried to explain on the last slide of presentation. So to in order to understand if the model learned right or not, we should evaluate it. So we should prepare a test data set that is statistically representative. And then we should run this data set as input for the model or the system as a whole. And after that, to calculate metrics, how accurate are predictions that we got on this test data set. And for example, in requirements, we should have a threshold of some metrics, and we should compare like are our predictions good enough for our app and our customers or not.
Okay, good. Thank you for your answer. We are waiting for your questions, and we have some questions in our VR community page. First of question: are there any tools that help testing ML apps?
Mhm.
Do you know some
Okay.
tools?
For testing ML endpoint generally, you can use any tools that can be used for usual AP testing, like Postman or curl, just to send request with some data to endpoint. and validate how endpoint handles different various data and to validate the response that we get. And this is about just ML endpoint testing. Also, when it comes to data acquisition and test files preparation, you should work closely with your ML team, because this is really project, really data, and really app specific. And the same basically for data generation tools. For example, if we don't have enough real data, we can use some tool which is like found or maybe even implemented by your ML team, and we can use this tool to generate some synthetic data that is representative. About performance testing, I think we can use also any tools that can be appropriate for our specific use case. We just need to use the correct and the good data, which we already discussed.
Okay, thank you. And we have in question in our chat. Is there something like accuracy percentage measurement for a mile?
Yes, sure. So, as I already mentioned, we have a lot of metrics. And yes, this is the example actually of the simplest of metric, which is really used in real life. And it is called simply accuracy. So this is like the percentage of correct predictions among all predictions. But actually, we have much more different metrics that help to numerically evaluate, like in percents, how accurate and to evaluate the quality of predictions that we generate. So, like general answer to your question, yes. We measure the accuracy of predictions that generate ML model, like in isolation, and also when it's integrated in the system end to end. So we measure metrics.
Okay. Yes, thank you for your answer. We are waiting for questions, and we have another question in our portal. Is it a bug when system makes an inaccurate prediction? Do we need to create a
Actually,
bug
this
report?
is yeah, thank you. Actually, this is a good question. Well, generally, to properly evaluate accuracy of predictions, we calculate metrics on the test data set. They allow us to assess, to statistically assess the quality of predictions fully that we generate. Um, and as I already mentioned, mistakes in predictions are almost inevitable. Um, but we have some quality threshold of certain metric to understand if the model is good enough. So, for example, we can have like 90 or 95% accuracy threshold, which will decide if our predictions are good or not good enough in general. So bad predictions is not really a bug, on my opinion, but it depends on the case. Because if there is some crucial special use case that could be handled like um, with some separate, with some custom approach, this is a bug. But in general, some errors is not like a separate bug. So if you, for example, take two test files and it failed on one file and on the second file, this is not two separate bugs. This is like just the errors in predictions. And if statistically our model is not good enough in terms of accuracy of predictions, it just will fail the evaluation and calculation of metrics on the test set. But as I already mentioned, I would like to encourage you like to collect these test items, maybe that you use for some functional testing, that on which the system fail, for example, misclassifies something or poorly detects something, because these failure items can help to improve the models or pipelines in future. But generally speaking, we mostly rely on metrics calculation on data sets, because this is like a general statistical approach. But in some specific use cases, this could be a bug when model misclassified or predicted something badly.
Mhm.
I hope I
Okay, thank you
answered
for your answer.
this question.
Yeah, thank you for your detailed answer. And I don't see questions in the chat. If you will have some questions, you can write, and Vladimir will answer in our chat. And thank you, Vladimir, again for such
Mhm.
interesting tech talk.
Yeah, thank
Please
you.
write your thank you words in chat, and you can send badges. Yeah, and we have one question. Sorry,
Mhm.
could you give an example of a simple test case similar to the real one or for testing email?
Yeah, sure. So, for example, in our case with system, let's actually approach from the more like simple case. So we have an endpoint where our ML model is deployed. So the example of simple test case would be to firstly uh, yeah, and let's, for example, we have an endpoint where image classification model is deployed. So it expects images as inputs, and we expect from this model output like classes for these pictures, like dog, cat, duck, and maybe some other animals, like in our simple example. And in this simple test case, firstly, we should prepare test data using some testing techniques like border values, um, uh, and apply this technique to some properties of data that we'll deal with. So, for example, in our case with images, we can find images, some really big images, or contrary, some really small images in terms of maybe file size of these images, like some different file formats of these images, or maybe some areas in pixels of these images. And then we use some tool for API testing like Postman to send requests to this endpoint, and then to verify the response of our endpoint. Firstly, just whether it follows the contract that we expect, so the format of the output, like if the output is even valid, and so on. And I think this is the simple example of just testing of ML endpoint.
Okay, thank you for examples. And I think we are done with our tech talk about email. Thank you, Vladimir, again.
Thank you.
And our next, yes, thank you. And our next speaker is Milena Laisova, software engineer. Her topic is about relationship between QA and developer team. Hello, Milena. Now Milena will start her TikTok, and I remind you about our feedback form. You can find it first message in our chat. Please leave your feedback. It's very important for us. And yes, let's start. Over to
Yeah.
you, Milena. Thank you.
Thank you, Arina. Hello, everyone. And today I'm going to go through a few scenarios showcasing how to get QA engineers and developers work together. My name is Milena Listova. I've been working as a Python developer for almost 3 years, and 1.5 of them I've been working for EPAM. I have experience with many technologies, but my primary skill is backend development. I have worked in different teams with different tester to developer ratios. And let me start with the question, is there an ideal tester to developer ratio? One tester for every 3 developers, one for every 4. Maybe you can't afford to have any bugs in your product and you will go first class. One tester for every developer. This may sound outlandish, but according to the book Microsoft Secrets, that's the ratio that the company uses. On the slide, you can see the results of a survey that was conducted by JetBrains company in 2020. 3/4 of the respondents claim there are fewer than 3 testers or QA engineers for every 10 developers on their projects. And only 3% responded said there are 9 or more QA engineers per 10 developers on their projects. So again, according to the book Microsoft Secrets, Microsoft employs a 1-to-1 ratio of testers to developers. This ratio is great when you have developers who don't know much about testing and testers who don't know much about development. A developer-tester pair can work together to release a new feature, and because they're both so focused on that one feature, they may be able to find and fix all the bugs. However, the developer probably won't contribute to any test automation, and the tester will likely to be the only one who knows how to run and fix the automation. The next scenario is one tester to 3 developers, and we can paraphrase it into 2 testers and a team of 6 developers. This is a very common scenario. The testers can divide up the stories to test according to their skill set and availability. However, this ratio will occasionally result in bottlenecks when there's a feature that needs a lot of testing or if one tester goes on vacation. The maximum ratio, which was found during the informal poll of participants from 29 organizations in some conference session, was 1 tester to a team of developers. In this scenario, the tester becomes a quality coach. They are not responsible for all of the testing or all of the test automation. They guide and train the developers to understand what should be tested and automated. In this way, the whole team owns quality. And last but not least, 0 testers to a team of developers ratio. Some might cringe in horror at this idea, but a team of very well-trained software developers is capable of doing all their own testing. In order for this to be successful, developers need to understand the importance of exploratory testing and how to create test plans. These ratios all have a few things in common. Most importantly, at least one person on a team needs to have excellent testing skills. Those skills are necessary to find elusive bugs. To sum up, in the reality, there is no ideal ratio. It depends on the product, on the budget, on the roles that programmers and testers play on the team, and so on. All these considerations lead us to the question, is QA necessary or should developers do their own testing? In my opinion, as a developer, we do need QA engineers. And the main reason is that developers and testers usually see things differently. A developer does what they're assigned to, which is write the proper code that addresses a specific function, which means that their scope can be limited on how their piece fits the bigger picture for the backend user. QA engineers, on the other hand, focus on making sure the piece provides satisfaction for the overall user experience, bringing in the user's perspective. Developers and quality assurance engineers are the bread and butter behind a software product, but with mismanagement, poor communication, and lack of action can make them into water and oil instead. Developing a software app is an act of collaboration, and bad teamwork can cause severe time loss, frustration, and of course, low-quality products. Given what was discussed earlier, there are a number of complaints that crop up in the product development team. First, complaints about the project being finished according to guidelines, but QA teams moving goalposts. It seemed to happen to the best of teams, and after working hard on a project and completing everything to the best of their ability. While the development team might feel that the job is complete, the QA process has only kicked off and starts to find defects and issues. The next complaints are about the dev team being unable to recreate issues raised by QA personnel. One of the most frequent complaints of any developer is, "It works fine at my end." This can be caused by the dev and QA teams not communicating clearly and objectively enough to understand the root cause of a problem. The next issues can be discovered too late to be resolved in time for the launch. DevOps is all about speed and fast feedback loops. Bugs need to be identified early enough and communicated to the dev team for a fix to be made and regression tests to run in order to get the code ready for production. Poorly coupled processes create roadblocks to the smooth functioning of software teams. And there are also some complaints about that the QA team receives too many models with buggy code. QA teams are often under enormous pressure to test and verify code for production or merge. Developers might often fall into a pattern of delivering buggy code and correcting them once the QA team comes back. This can be both a roadblock in terms of accelerating release velocity and lead to internal departmental tension as well. From here, we can see the potential conflict between the two. In one hand, the coding is complete and it does what it should do, while the other believes that it could be executed better. So what are the good ways for better collaboration? And the first way is by using Agile. Since waterfall is a downstream process, programmers and QA engineers work independently and therefore rarely practice communication and project engagement. When product developers and QA teams work by waterfall model, they practice this frequent disconnect, since the software testing is performed at the end of each coding phase. Agile methodology requires organizations to rapidly respond to the changes in project development. To really be agile, the companies need to have their QA and development working together at the project start. Agile team has a developer and QA engineer involved in the current sprint to both code and test a feature. By doing so, a team adapts to changes and iterates the product development process. The next way is via a team approach. In a team, everyone has a definite role to play and no one can perform independent of each other. So it is important to develop a via team approach. It is very important to encourage interaction between QA and development from the first day of the project, as it helps to develop clarity and set aside misunderstandings. Most of the time, QA teams and development teams are busy pointing fingers at each other. If both teams understand that the focusing on building a superior product together, these problems can be easily resolved. It is also very important to understand and respect each other's roles. In order to have a healthy process and great end product, the developer and QA relationship should be one of mutual respect. Testers need to be tactful and tolerant while pointing out people's mistakes. Their work is to find faults in others' work, so they need to realize that for some people, this might be difficult to accept. On the other side, developers should understand that bugs are nothing personal. Despite the fact that bugs actually mean more work, longer hours, project delays, and estimations getting turned upside down, developers can always do their best to minimize or even get rid of these conflicts. It's also helpful for developers to keep in mind that QA's goal is to proactively improve user experience and quality. When developers feel comfortable with and respect their QA colleagues, they can rest assured that bugs are being reported in a natural, objective way. There is always a question, to bug or not to bug. A good QA tester will have an eye on user experience that goes above and beyond strictly reporting glaring defects. As a result, sometimes QA will report user experience issues that a developer may not think of as bugs. So when this happens, it's best for everyone to let the project or product managers prioritize the bug fix. A developer may have followed the acceptance criteria perfectly, so QA reporting a user experience issue does not inherently mean that the developer did anything wrong. QAs usually begin communicating with developers with their report logs, then continue to talk by following up the logs. This is not only slow, but also inefficient. Both QA and developers must be discussing and checking up on each other's progress as fast as the fast-paced workflow in the IT department. QA must already know what the developers are making and what projects they have tested, manually or in code. Developers must understand the vision of the QA on what makes a perfect or acceptable product from the QA. It is helpful to encourage any formal and informal interactions. Visibility improves collaboration and builds trust among teams. Developers and testers are no exception. It is very important to provide visibility into your activities. Do not just assume that the development team, clients, or any other entity know what you're up to or what testing procedures and standards QA team is using. Transparency is one of the essential communication skills that help build most collaborative teams. Keeping moral high between team members can go a long way in making a project successful. Of course, avoiding unnecessary negativity and disputes is important, but going a step further and actively cultivating good vibes can reduce stress and misunderstandings, and even improve the quality of the app or site. So the positive encouragement from QA team to developers and vice versa is very important. And now let's discuss some useful approaches for better collaboration. I want to start with a very popular approach named shift-left testing. Traditionally, the role of a tester might not even begin before the developers are done with theirs. However, if you wish to deliver robust web applications faster, you need to incorporate testing in your CDLC as early as possible. Shift-left testing is a methodology that emphasizes on testing as early as the requirement gathering phase. That way, testers can think of possible scenarios where they may encounter bugs. Shift-left approach is nothing but involving the testers much earlier in the software development lifecycle, which in turn would allow them to understand the requirements, software design, architecture, coding, business analysis, and so on. This involvement and understanding will lead the testers to gain complete knowledge about the product. Think through various scenarios and design real-time scenarios based on the software behavior, which would help the team in identifying the defects even before coding is done. And what are the benefits of the shift-left testing? It's well known that the sooner bug is found, the cheaper it is to fix. With shift-left testing, it's possible to detect in real time the exact moment in which an error was inserted into the system in order to resolve it in a timely manner. Beyond these benefits, being able to start testing sooner invariably results in a high quality product, as testers are less rushed to find all the errors at the end when there is little time left to fix them. Another great benefit of shift-left testing is the ability to use test automation tools. As we want to test early and often, test automation helps you to accomplish these goals. We don't want to overload our testing team with manually testing every new feature the development team introduces. In addition, shift-left testing fits nicely into the agile idea. There are also some disadvantages of these approaches. For shift-left testing to be a success, an often drastic change in culture must occur first, which requires a team effort. A drastic change in culture is not easy as teams are not ready to leave their comfort zone and traditional ways of working. In addition, there could be some bottlenecks. The risk of bottlenecks is common owing to composite apps and the complexity of environments, making agile teams get stuck. Another good approach is QAOps. And QAOps is an emerging methodology for modern-day release cycles where the QA is expected to be synchronous with the DevOps team. The idea is to perform continuous integration plus continuous delivery plus automation testing all together. So you might have a CI/CD pipeline which is regularly committing changes to the code in one environment to another through Jenkins or your favorite CI/CD tool. Meanwhile, you have your test automation scripts configured as jobs, which are ready to be fired up as and when the code is committed. So that way, both testing and development are assimilated simultaneously in a cyclic manner. When QOps is integrated into the CDLC, it provides high-quality software products compared to the traditional method. QOps allows the development and QA teams to work in coordination that eliminates the ambiguity between different teams, providing better results. Along with the faster delivery, QOps also ensures the quality of the product. Despite these benefits, sometimes QOps is hard to implement. CI/CD process may not be set up for test automation, which could an additional overhead and become difficult due to organizational restraints. In addition, QA team might lose focus on QA activities or have too high a learning curve that can slow them down. QOps is the next evolution of DevOps and looks at inserting high quality at the core of the delivery pipeline. However, there are some differences between these two approaches. So for DevOps, QA can function only as a subset of development. In QAOps approach, QA specialists work collaboratively with other team members. In DevOps, it is important to deploy software rapidly. On the other hand, in QAOps approach, it's important to guarantee the quality of software. Another good approach is to let QA team participate in code reviewing. In many organizations, code reviewing is an activity where there is hardly or little participation from the testers. However, understanding the code base and its working is not exclusively a developer's task. Testers must design test problem the correct areas. Learning from each other makes this task easier. Moreover, tester can also easily spot errors. Thorough knowledge of each other's equipment and tool will further benefit both testers as well as developers. Consequently, a developer can benefit from understanding the QA process and test suite. It helps write an easy-to-test and stable code. This approach is not a perfect decision because it's usually not easy for testers to understand the code. In addition, code review might get longer than expected. It might delay the development process. And as for my own experience, I have never worked in a team without QA engineers. It is always a challenge to find the best way to collaborate, but I learned some useful tips. Firstly, I believe that QA engineers should participate in the discussion of tasks from early beginning. It is a good practice to involve your QAs into sprint planning, and I'm talking about agile teams where I worked. Secondly, I always have a short discussion with the QA team before submitting the task. We share our vision on the implementation and how it should work for both sides. Thirdly, it's nice to have something like a code freeze day, and I'm not talking about the release. What I mean is to have a code freeze day each sprint to help QA engineers test all tasks on time. For example, your sprint starts at Wednesday, and next Thursday would be a great code freeze day. I also think that it is a good practice to break large tasks down into smaller pieces to make them easier to test. This will save a lot of time because developers and QA team can work in parallel. And last but not least, in my view, if developers can somehow help QA engineers, they should do it. I know that it sounds a bit obvious, but what I mean is it's great to be in touch with your QA engineer. Discuss your tasks, discuss your solutions and implementations together. Discuss some problems, possible risks, answer questions. When I complete my task, I always put some comments to help tester to understand what I've done, how he can test it, and how it exactly works. If the comment is too big, I schedule a meeting to discuss it. In words of one syllable, I'm always there to help. And I believe that developers and QA testers both serve crucial roles in the software development lifecycle. By working together, the result can be greater than the sum of its parts. This means less stress, more productivity, and a smoother experience for everyone from the engineering team to the end users. At the end of the day, the benefits of fostering a great QA developer relationship are well worth the effort. So I guess this is all I wanted to tell you today. Thank you for your attention, and if there are any questions, feel free to ask them now.
Yes, thank you, Milena. And we are waiting for your questions. Thank you, Milena, for such talk. I think it's always actual topic for us, for testers and developers. And we have some questions in our portal. First, how to avoid conflicts between QA team and dev team? What do you think?
Yeah, this is also this is a great question, and it's not very easy to avoid conflicts. But first of all, yeah, I believe that at the very start, you need to start your project in a good environment with a team approach. And if you are in the middle of the project, so it's best to not attack the person, but attack the issue. Never go personal while disputing with the person, and do your best to keep things on a professional and polite level. It's always good to listen to other opinion and pay attention to what other people are talking about. Look at the problem from their point of view. It's also good to stop judging somebody's idea. It's important to understand the right way how to handle conflicts, but it's even more important to realize that conflicts may encourage many new ideas and opinions. Sometimes it's better to facilitate healthy conflicts rather than getting rid of it. And it's better to facilitate conflict resolution. There are many various options, but one of the most effective is to motivate team members to resolve their problems by discussing them together. If people keep standing their ground, make them prove their point of view. Something like that.
Thank you. And we have very interesting question in the chat. Why testers and developers fight all the time?
Yeah, it's a very good question. I believe because we have different point of views. As I mentioned at first slides, that we see the picture differently, and we are trying to do it differently. So for developers, we just want to do something that can work. So it works fine for us. As a QA engineer, I believe that they need to test it properly, and they always want to break something, to find bugs. Sometimes it's very difficult for QA engineers because developers try to build something and QA engineers try to break it. That's why I think this is the main conflict, why testers and developers fighting all the time.
Okay, thank you. And I think the question for me, can we get presentations? If you mean presentation of our tech talks, no, we will not send our presentations. And next question from our portal, how to achieve shift left testing approach?
It's also a good question. It's not exactly the theme of this topic, but there are several steps, so it's not very fast. There are no fast solution to achieve shift left testing approach. But first of all, you need to bring your developers into testing activities. You need also introduce testers to coding. You need to include your testers early on early stages, so before a task is submitted, and so on. And it's also good to keep testability in mind while coding. So as I mentioned also that shift left testing is nicely fits in Agile. So yeah, to be short, there are some, that was the steps to achieve shift left testing.
Yeah, okay, thank you. And another question, what's your ideal tester to developer ratio?
Well, my ideal tester to developer ratio, I don't know, but I believe it's one tester to one developer, or maybe one tester to two developers. I think that's when it's when QA team is big, it's so good, it's so nice. So yeah, I think like in Microsoft Secrets book, my ideal tester to developer ratio is one tester to one developer.
Great, thank you. And we are waiting for your questions. We have one question and we are waiting for comments. Another question that we have, it's about QAOps and DevOps. What is the key difference between QAOps and DevOps?
Mm-hmm. If you don't mind, I will share the slide with the difference again. And yeah, here you can see some main differences between these two approaches. And as I said, that QAOps, it's like the next evolution of DevOps approach. And the main difference, I believe that the main difference is that QA is not like a subset of development. It's a member of a team. QAs work collaboratively with operations and developers. And there is also another difference in the idea of QAOps. The idea is to guarantee the quality of software. So it's not just to deploy software rapidly, it's about the quality. And that means that the software app's quality can be excellent in this case.
Okay, great, thank you. And we have comment from Irkan about slides. Yes, Irkan, we are not sharing presentation slides. We are not sharing it. And another question from Irkan: is there a ideal number of manual and automated testers?
It's very difficult to answer this question, as well as to answer what is the ideal ratio tester to developers, because it depends. It depends on the product. It depends on the team. It depends on the budget. Um, so I believe that we cannot know the ideal number. But from my experience, usually there's only one automated testers to 2 or 3 QA engineers. So usually there are less automated testers than manual testers.
Okay, great. Thank you. And I don't see another comments and questions. Thank you, Milena. Thank you for such interesting tech talk. Please send the badges and thank you words to Milena. And
Thank you.
thank you all for participating for our conference. And Milena, can you please open next slide? Yes,
Sure.
we want to invite you for our next tech talk. Now we will send link in the chat. Our tech talk will be about Scrum. Diana will be our speaker, and we are waiting for you. We are starting registration, and it will be in February. Yes, and I remind you about our feedback form that we have. Please it will write your feedback. It will not take more than 5 minutes, but it's very important for us. And also we will share our social networks in the chat. You can join us. We have a lot of interesting and important information about testing. Thank you again, Milena. Thank you all, and goodbye. See you
Yep.
on
Thank you for your
February.
attention.
Thank you. Bye.
Thank you.